Let's begin our discussion on subnetting. Subnetting addresses the issue when you divide your network into subnets, how will the new network IDs be assigned? Here's the example. We have three buildings, Building A, Building B, and Building C. And you have been assigned the job of installing a new network in Building B. And you've been assigned network ID of 131.15.0.0. So all of the computers in this building must start with 131.15. Now, Building A will use network ID 131.14, and Building C will use 131.16, but 131.15, that's us. So what you do is you install the computers and you give the first one the IP address of 131.15.0.2, and you give the next workstation an IP address of 131.15.0.3, and the next workstation .4, and then the router gets the IP address of 131.15.0.1. The router does not have to be 1, but it usually is, just by convention. So you get that all installed, and remember your network ID is 131.15, therefore all computers in the network must start with 131.15, and that's what we do. And then you've been told to install another network and to connect the two networks with the router. So you take your existing network and you install a new network and you connect the two networks with the router. And now you need to assign IP addresses to all the computers in the new network. And the question is, what network ID will they get? Will it be 131.15? No, you can't do that because this network over here is already 131.15, and you can't have two networks with the same network ID. Well, it's got to be something that's not that. How about 131.14? No, can't use that. Building A is using that. How about 131.16? No, can't use that. Building C is using that. So what can we do to get an IP address, or I should say a network ID, for this additional network? The question is, what network ID do you assign to the new network? The problem is we have only one network ID, and we're already using it on the first network, and we need a network ID for the second network. And the solution is subnetting, where we use the third octet for subnet ID. Subnetting involves moving the subnet mask to the right. We can move it one octet to the right, or more, or less, and then use that third octet as subnet identifier. So let's do it. Before subnetting, the subnet mask is 255.255.0.0. But after subnetting, I push the subnet mask one octet to the right, and the subnet mask is now 255.255.255, or you could say it's a 24-bit subnet mask. What we do is we use the third octet for subnet ID. So what I do is I give every computer a subnet mask of 255.255.255, and I now use that third octet for subnet ID. So my first network is network 1, subnet 1. And then the second network is subnet 2. And if I slide this whole thing down and to the left, I have 4 networks connected. And they all begin with 131.15 because that was the original network ID that I was assigned. But the subnet ID resides in the third octet. So this is subnet 1, subnet 2, subnet 3, and subnet 4. And this is what subnetting is all about. In subnetting, we move the subnet mask to the right and then use the third octet as the subnet identifier. Calculating the new subnet mask. What does subnetting do to the number of network IDs? It increases the number of network IDs. And what does it do to the number of host IDs? Well, it decreases the number of host IDs, and it can decrease them by a lot. So the question is, how far to the right should you move the subnet mask? And the answer is far enough to give you enough additional subnet IDs, but not so far that it reduces the number of host IDs by too much. So let's look at the first example of moving the subnet mask a full octet to the right. We start out with a subnet mask of 255.255, and we have 16 bits with which to assign host ID, and that's plenty of bits. We move the subnet mask 1 octet to the right, and that's good. Now we have a full octet with which to assign subnet ID, but now we only have 8 bits with which to assign host ID, and that only gives us 254 host IDs. So another solution is to not move the subnet mask 8 bits to the right, but 3 or 4 or 5 bits to the right. So let's look at an example of moving the subnet mask only 4 bits to the right. If we move the subnet mask only 4 bits to the right, okay, originally we have 16 bits, and then we add 4 more bits. These 4 bits can now be used to assign subnet ID. And it still leaves us with 8 bits in the host ID, and that's 4,000 potential IP addresses. So by assigning the subnet mask only 8 bits to the right, only 4 bits to the right, does give us 4 bits for assigning subnet identifier, but it still leaves 8 bits for host ID. Page 248 addresses how to calculate a new subnet mask. 4 steps. Determine how many subnets are required. Determine how many bits are required to represent the number of subnets. Convert those bits to higher order bits, and then convert to decimal. So here's the example. The example is we are told we have to divide our network into 15 different subnets. So, how many subnets are required? 15. How many bits are required to represent the number 15? And the answer is 4 bits. If we convert those 4 bits to higher order bits, we have 4 ones followed by 4 zeros. And if we convert to decimal, we get 240. So this is a subnet mask that only moves the subnet mask half of an octet to the right, and that's why it's represented as 240. If we move it a full octet to the right, it's 255, but if we only move it 4 bits to the right, it is 240. In summary, to increase the number of network IDs, we move the subnet mask to the right. And this concludes our section on subnetting.